So far in the basketball season, during games, Charlie has shot 30 free throws. Unfortunately, she's only made 13 of them. Up to this point, what's her stat for percent of free throws made? 13 over 30. Well, what is 13 over 30? Give me 3, please. 3 decimal places. May I please have 3 decimal places? So 0.433, right? So it's approximately equal to that. So what's the percentage of free throws made? 43.3%. Correct? After such a poor start, Charlie just quit. And then she got her mom to complain to the coach. Oh, that's not what it says? Oh, okay. So after such a poor start, she gets some advice from the coaches and practices daily. Isn't that a better choice anyways? Okay. If she does not miss another free throw for the remainder of the season, how many consecutive free throws will she need to make before her percentage reaches 80%, 90%, or 100%? So let's talk through this table for me real quick. Okay. Right now, she's at 13 over 30. Her decimal, we're going to go to 3 decimal places here. So her percent would be 43.3%. Right? What about if she makes one more? Now, I know it says it already right there, but how do you know it's 14 over 31 and not just 14 over 30?
Because it's another one.
Attempts over... makes over attempts, right? How many she makes over how many she attempts. So what would this decimal be? 0.452. So what would be the percent? 45.2%. Okay. What about if she made 2? 15 over 32. 0.469, so 46.9%. Somebody else, give me 3. If you've already done one, keep doing it, but don't say it out loud. Somebody who hasn't talked yet, tell me 3. Oh yeah, you probably need to get your calculators out. Good idea. Say it again. 16 over 33. Good. 0.485. So the percent would be? Excellent. Somebody else, give me 4. $17 over 34. But we don't even need our calculators for that one, right? 0.5. So 50%. Okay. What about 5? 18 over 35? It's okay. So that would be that's not what I got. 0.514. So 51.4%. Would your group do 10? Talk about it all together. Do 10 all together. Would your group do 20? Would your group do 50? 100? Okay. Just discuss. Discuss with your group. Come to a consensus on an answer. And then I'll ask for your answers in just a moment. Okay, do you guys have 10 ready?
Yes.
Okay, what do you have?
23 over 40.
23 over 40.
0.575 and 57.5%.
Excellent. 20? Do you guys have 20 yet? Do y'all have 50 yet? What you got?
63 over 80.788 and 78.8.
Okay.
This would be like a pretty good regression.
20? You guys ready yet? 100? Are you guys ready yet? No? Okay.
We have all of the at the end of the state game, they just celebrate because we're the next to be the entire game. Yeah. So it's normally pretty good regression.
Do you guys have 20 yet? Okay. Okay. So do you have it yet? Okay. 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 So what's the fraction to begin with? 33 over 50. So 0.66. Is it exactly 0.66? Awesome. So 66%. Oh, true. Yeah, true. Okay. 100? You guys ready yet? What you got?
113 over 130. 0.8669.
Okay. So we have one more box to fill in right here. Let's come back together as a group. What's our one more box to fill in right here?
Our fraction.
So for x, right? Not a specific number, but x. What's our box going to look like?
Is it like x over x plus 17?
It's a good guess.
X over y plus 17?
There's no y. No.
Oh, would it be like 13 over 30 plus x?
Closer. Look at the fractions right above this and see if you can see a pattern. To me, this one's the easiest to see. Because I started here, and now I'm here. So x plus 13 over x plus 30. Does that make sense? Okay. So what equation relates these two quantities? Now, first of all, we know we're going to use this, but this is just an expression, but it wants us to figure out the relation. But the other thing you have to look at is what it's asking for. It's asking for the number of extra consecutive free throws and then the percentage. So is this right here the percentage? How do we get to the percentage? Thank you. I've been practicing asking great questions lately. What did this give us? The decimal. How did we get from the decimal to the percent? Oh, just magically we moved the decimal? Close. Multiply by 100, right? Maybe you've always been taught that we magically move the decimal, but I need you to understand the math behind it. We're not magically moving a decimal, we're multiplying it by 100, right? Okay, so what we're going to put in our calculator is x plus 13 over x plus 30, and we're going to multiply that times 100 to get what our graph looks like. Okay, so far? So when I put it in, mine looks like this. Yours look like that? I changed my window just a bit to be what this window is right here. Do I need to show you how to do that, or you remember how to do that? You're fine? Okay. After how many consecutive free throw will her percentage reach 80%? Is there a way to figure it out?
You could guess and check.
We could guess and check. You know how to solve this equation right now? Let's not make it too hard on ourselves. If in our calculator we already have the fraction of x plus 13 over x plus 30, couldn't I add a table? Control T?
A table, wow.
Couldn't I look at a table? What am I looking for in the table?
When it's above where we're at immediately.
So when it's okay, so Control T. Let me get my table. Oh, 55. So answer the question. Uh-huh. After 55 free throws. Charlie will reach 80%. Will that work? When will the percentage reach 90%? Oh, look at the table. Okay. Looking at the table. Whoa. 140. After 140. God bless you. Free throws. Whoa. Charlie will reach 90%. Okay. Oh, it should though, right? Why? And before we even started keeping track, she'd already missed 17, right? Okay. So let me show you this one. Hopefully I didn't mess it up. I did. Last period I got to 5,000 something. Just sitting here like this. I'll see if I can do it this period. It was just hurting my thumb. Take turns. We'll just pass it around. Okay. So first of all, when will it reach 100%? Never! Never! Because she's already missed some. Okay? You spelled never wrong? Sorry. Often when using rational functions, when you plug in a larger and larger number for x, the answers for y keep getting closer and closer to a certain value. This value is called a limit. That is a calculus term right there. Okay? A limit. It's approaching that number. Will it ever get there? No. And you know why. Because there's a horizontal asymptote there. Look at what our graph looked like. This is approaching 100, but look. Look what's at 100. An asymptote. Nothing can be there, right? This graph will get closer and closer and closer to 100, but it'll never get there. You understand mathematically why it'll never get there. You told me a second ago because she already missed some. We can't get to 100%. Okay? So in the basketball problem, what was the limit on her percent? 100%. Graphically, this makes an asymptote. What kind of asymptote? How do you know that? Yeah, it's the title of the worksheet, first of all. Okay? But second of all, if you look at the asymptote, isn't it a horizontal line? Yes, right? Okay? So horizontal. Okay? I need to give you some reminders. All right? Asymptote. We don't need to unnecessarily stress the first syllable of the word. We don't abbreviate it, because even if it did, it would be ASY and not what you want it to be. Okay? And we don't need to probably go around in the hall telling each other we're going to kick each other in the asymptote. Okay? Because someone who's not a math teacher might overhear you and send you to the office. And then the principal might say, "Why are you saying words like that?" And then you might say, "Oh, Mrs. Kingston taught me." And then I will get called to the office. Oh, yes, it has. And I was feeling pretty, what's the right word?
Triggered.
Triggered about that. And so they were like, I mean, what is it? And I was like, nothing. It's nothing.
It's an inside joke.
Because it's nothing, right? Nothing can live where the asymptote is. But then that made my principal not very happy because I was teaching words that sounded like bad words. So I finally had to explain it.
Who's the principal?
Not Mr. Wilson. Mr. Wilson and I have already had this conversation in case he hears the word or something. So, but it was kind of funny, but also I was triggered. Is that the right word? Okay. Salty. I mean, I don't know. There's several words that I could use to describe it. Yeah. Okay. So,
Big mad.
if you're gonna say something like that, say it in the room or don't. Or make sure there's a math teacher around to explain what you're talking about. Okay? Or just don't be angry at other people and tell them you're going to kick them. I never tell people I'm going to kick them. Okay, so let's go to this page. Okay? Predict the locations of this type of asymptote by finding a limit or plugging in extremely large numbers for x. Now, are these extremely large numbers
They're big, but they're not.
compared to what we used before?
Yeah.
1, 2, 3, right? We're not looking at sissy pansy numbers like 1, 2, and 3. We're looking at 1,000, 2,000, 3,000, 4,000.
And then we have to multiply by
Yeah, be
100
quiet.
every time, right?
We don't. We're only looking for a number. We're not looking for a percentage. Okay? So here's what I want you to do. Okay? I know there's 8 problems on here. There's 4 groups in here. Okay? I'm going to split this group right here into 2 groups. So be partners somewhere, either beside each other or across. It doesn't matter. Okay? Who's your partner? You guys do number 1. Okay? You guys do number 2. Now, when I say do number 1 and do number 2, all you're doing is filling in the table. That's all you're doing. You're figuring out a way to use this equation and substituting these x values in to fill in the table. Okay? You guys do 3. You guys do 4. You guys do 5. Okay? Once you and your group or your partner fill out your table, somebody come back here and put it in on my paper under the screen or under the projector. Okay? So once you get it done, send somebody back here to fill it in. What?
How do we, foundation?
Depending on your numbers, we've been using 3 decimal places, but depending on your numbers, you may need to go to 4 or 5 to get everything that you need. Okay? But as soon as you get your table done, come back here and fill it in. Only the table. That's all we're filling in right now is the table. Good. Looks good. Not in here. Got it done? Okay. Done? Thank you. It was just like a line from the pen. It's not there. That's nothing. Except you can't have just 3 for the third and the fourth because then they'd be the same and you want more specific. Sure. That's right. You're fine. I just have the numbers. Yeah, just don't put decimals on those. You see why though, right? You see why? Yeah. Okay, I just need one more. Okay. Thank you. Hmm?
Jacob thinks it needs to be exact. Just gonna fix this for him. Oh, this is gonna bug me.
Are you doing your own problem?
No, I need to fix this. I need to put an 8, but like I don't want to.
I don't understand what you're messing with.
This. Jacob claims, or they claim it needs to be exact, so There we
Okay.
go.
Wait.
Okay.
I thought we did this wrong. Oh, is it like most letters?
Yeah, you're fine.
Okay.
Yeah.
You're welcome.
Did you have to go to 5 decimal places or 6 on some of them?
Yep.
Yeah, that's fine.
In this case, it's 999 FC just no, no, it's not really.
Okay, you ready to talk about the asymptotes? So if we're talking about, I'll turn this back over in just a second. If we're talking about the limit that this is approaching, we're looking at the table and seeing where it's going. Now this one, we just use whole numbers and then even a bigger space. So this wasn't maybe as obvious as where it's going as our logical thinking, right? These are going to be a little bit more obvious where they're going, okay? Because of the fact that we're able to use real big numbers, okay? Where is this one going? What number is it approaching? What is it getting closer and closer to? 1. Y equals 1. Guys, why did I put y equals 1 and not just 1?
Because it's horizontal.
It's a line, right? It's a horizontal line. And if it's a line, I have to call it its name. And since it's horizontal, I know it's crossing the y-axis at 1. So I call it its name, which is y equals 1. Okay? What about number 2? Where is this getting closer and closer to? 0.5. Y equals 0.5. What about number 3? Negative 1.7 would be up here, and it's getting smaller, right? So it would be negative 1.6 repeating. What about number 4? Can you turn that music down? I can hear it back here. Okay. What about number 4? It's just going up. Is it getting closer to something, or is it just getting gianter? There's not one. What about number 5? 0. And what about number 6? Uh-huh. You're going to end up doing 7 and 8 for homework, so keep track of that. Okay. Is there a way to tell the location of the horizontal asymptote just by looking at the function? Yes. So how? Let's look at this page. First of all, we're going to look at the exponents. We're going to find the greatest exponent in the numerator. And we're going to find the greatest exponent in the denominator. Those greatest exponents are called? Do you remember what they're called? Uh-huh. Okay. So there's 3 options. Either the degree of the numerator is greater, the degree of the denominator is greater, or they're the same. Okay? If the degree of the numerator is greater, for example, number 4, what's the degree in the numerator on number 4? 2. It's right there, right? What's the degree in the denominator? 1. So can you tell the degree of the numerator is greater? If the degree of the numerator is greater, there is no horizontal asymptote. So that's why we wrote none. There's not one. That's if the degree of the numerator is greater. Okay? If the degree of the denominator is greater, for instance, number 5, see the degree of the numerator is what? 1. What's the degree of the denominator? 2. So the degree of the denominator is greater. Then you have 1 at y equals 0. That was the answer. Yeah, see? That was the answer. Okay? Now, what if they're the same? If they're the same, we look at the leading coefficients. Okay? For instance, if we look at number 1, the degree of the numerator is 1, degree of the denominator is 1, so I look at the leading coefficients. They're both 1, so I have y equals 1. Look at number 3. What's the degree of the numerator? The degree of the numerator is 1, highest exponent, right? Degree of the denominator is 1,
5 divided by negative,
which is negative 1.6. Okay? Fill out number 7 and number 8, and then fill out 1 through 4 on this page. Any questions?